In our previous video, we have done an example to copy three words A, B, and C from the location of 2000 to the location of 8000 in the memory. So we also introduced the new addressing mode pre-indexed with offset that we can actually modify changing the offset value, and so that we can easily load and store the value to duplicate that from a memory to a new memory location. Alright, so the way how we wrote the code is by increasing the offset to sweep the memory address that we need to copy as well as the memory address that we need to store. Of course, in this example, it seems to be easily solved since the numbers of the words that we need to copy and paste over there are only 3. So it becomes a problem if the number of the words that we need to duplicate or move to a new location increase, for example, up to 30. So it would be impossible for us to keep writing the same code to load and store over and over again for example, let's say you need to do it for 30 times. Therefore, in today's video, we're going to learn how we could implement a loop to repeating the same instruction set over and over again for a certain amount of time in assembly language. So today we'll start to look into the for loop. If you're familiar in C or C++, and we're gonna see how we could implement it using the assembly language for ARM. So imagine you have a for loop that it takes 3 parameters. So the first one is the initial value of I. So as long as I less than 30, and every time you perform whatever thing inside the loop, you're gonna increase I by 1, and whatever things that you have inside the for loop will be repeat, in this case for 30 times. So in this for loop, for example, the I start with 0, then after you complete the whatever process in between, I will become 1, and so on. I will become 2, and repeat the same thing again until I become 29. So once I become 29, and after you plus 1, it ends up to be 30, and this condition is no longer fulfilled, which is where the loop will break. So this is the condition that we preset in our for loop. So let's say we have a value that starts with 0, and we do a for loop, and every time we're gonna increase A by 1. So by the end of this loop, A will become 30. To implement such a for loop in ARM assembly language, we're gonna need 2 instructions. The first one is compare, and the second instruction is called branch. Alright, let's look at compare first. So the opcode for compare is CMP, and it takes the first operand as a registers, and you can use immediate value as the second operand. Branch, on the other hand, the opcode is B, and also there's a special case where you can put B in pair with the condition. If you look at the code that we wrote previously, the way how the processor executes the code is actually in sequence. So there are special registers that you have inside the ARM processor, which is called the program counter, or we call it the PC, which actually keep track of the line of the instruction set that you wrote and supposed to be executed by the processor one by one. The branch instruction is how it's used if you need to break the index of the instruction to a further away or go back to the line before above the instructions code. So for example, if I use my R2 as 0 and I would like to represent R2 as A, as what we our example above, then I can do add operation, right? I can add R2 with 1 and store the result into R2. So my R2 will start as 0, as what we initiate in the beginning. Then every time we encounter add R2 with 1, so basically it means RA equals to A plus 1, alright, as what we have in our for loop. So after this instruction set, so this value has become 0, 1 instead of 0, 0. So if I put a branch, which B, and the operand for branch is actually a label in the text form, so I could write anything I want. For example, again, and I would tell my processor where I would like to repeat or jump back to my instruction set. So of course, in our case, we would like to instruct our processor to repeat the add instruction so that we can keep increasing A equals to A plus 1, so that every time the processor loop through the process, R2 or A will increase by 1, and in this case start from 1 then to 2 and so on, as what we try to achieve in our C++ code. However, in this case, as you see, our processor will not stop. It will keep just repeating add, branch, add, and branch, and so on, and that's where your processor will start or hang over this loop. So therefore, we need to learn how to implement the condition as what we did in the for loop, so that the processor know after a certain amount of time he should not go back to it again, as what we wrote in the label. So the way how we implement it is by using the compare instruction. So compare, for example, we have R3, and let's say we want to compare with 30. And of course, if we need to initiate our R3 as what we did in our for loop in the beginning, so means we have to say R3 is also start with 0. So in our case, R3 is the I as what in our for loop, R2 is the A as what we have in the example just now. So R3 start with 0, R2 start with 0, and we go start adding R2 with 1 and store to the R2. And every time we do this, we're gonna compare whether R3 is equal to 30. Alright, then we're going to branch to again. However, even with this, your processor will not stop executing this loop. It's because that although we are trying to tell the processor to compare between register 3 with a number of 30, but register 3 is remain 0 as what we initiate in the first time. So compare is actually just look at these two values, and there's no operation to modify the value in R3. So in this case, I start with 0, and after the process in the loop, I actually increase by 1, and as long as I is less than 30, the loop will be continued. So as you could see, we did start R3 with 0, but we never increased R3 in our loops, although we did compare R3 with 30. So what we need to do is actually we need to add R3 with 1. And last, the thing we need to fix is on the branch. So if we use the branch as B alone, it basically means branch always. So whenever your processor found the B inside the list of your program, it will jump no matter what condition. So we have to put a condition, or we can put a condition after the B instruction or the opcode to jump based on the condition that we are given. So in this case, we're going to do it as long as I is less than 30. So the way how we implement it in the ARM processor is by using branch. The condition is less than. So less than is represented by LT. So if you read the codes once again, so we start I or R3 with 0, we start the 2 or our A with 0. So we're gonna add R2 with 1, and we're gonna increase our I or our R3 by 1. So we compare whether R3 with this value 30, we're gonna compare as long as it's less than R3 is less than 30, we're gonna branch to again, which is there. And the things going to be repeated. You add 1 to R2, you add 1 to R3, you compare whether R3 and 30 is less than 30. If yes, then you're gonna branch. So until a stage where your R3 is equal to 29, and you add 1 to R3 and to make it to 30, and you compare 30 with a 30, and you're gonna decide whether should you branch or not based on this condition. And since R3 is not longer less than 30, then this branch will not trigger. So at this stage, the processor will basically skip the branch and go to your next instruction after the branch, which whatever you have afterwards. Now let's redo our example or our exercise in our previous video, where you need to copy the value from a memory, which is ABC, and duplicate it to a new location. So assuming the address was 2000, 2004, and 2008, and we have to move it to 8000, 2004, and finally 8008. Well, we could begin by initiating two address pointer, which is R0 and this is equal to address 2000, and we can do the same thing for R1, but at this time R1 is pointing to 8000. So we're gonna solve the problem using the loop based on the compare and branch instruction set. So I might need another registers to be used as the I or the index for the loop. So if I load R2 with 0, basically R2 is equal. So the way we solve it in the last video is by having load the value for memory of R0, then we store the value back to the memory pointed by register 1. And again, in later case, when we need to move 4 or 8 to 8004 and 8008, we start to introducing the offset the immediate value for 2004, and later on we change this value to 8 if we need to move the value from 2008. So since we need to do the codes in a loop, so I would like to represent the immediate value to something that I can modify, so which is as you see. And in our case, I can use one of the registers to represent or to hold the immediate value that I need to offset the register 0. So let's assume I use R4 as the registers to present the amount of offset that I need. So I will start my R4 again with 0. So of course we're not gonna need this anymore. So in our codes for load R3 from the memory where the address is given by 0 and the value is offset by R4. So of course in our current R4 the value is 0, so this is 2000. So basically we are getting the value from A and put it in the R3, which is our destination. So for the same thing, we can repeat the process by storing R3 back to the memory, and the address of the memory is given by R1, and I also would like to offset it with R4, although current R4 is 0 as what we seen just now. So the address at this moment, the address is given by R1 plus R4 is still 8000, similar to the value of R1. So in this case, we already successfully duplicate the A by using register 3 as the immediate medium. So as you remember our previous discussion, if we need to repeat the loop, every time we do it, we have to increase our I or our index, which is register 2. So we could do it by add R2 with 1. So R2 after first round of the loop, R2 will become 0x01. Then we can compare register 2 with 3 because we're going to do it 3 times, and we're going to branch as long as R2 is less than 3, and we tell the processor to go to repeat. Of course, repeat is a label, you can put any words you want, but the important thing is where we should repeat. So in our case, we're going to repeat over there. So every time your processor repeat the loop, we will go to redo the load instruction, moving to R3 from the memory as given by the square bracket, and the address is given by R0 plus R4. So R0 is 2000, R4 is 0. Then you move A to R3, and then at the same time after that you store R3 to 8000 from R1, which is 8000, and R4 is 0. So we increase our R2 by 1, so R2 will become 1, and we try to compare R2 whether it's with the 3, whether it is less than that number. If yes, then we're gonna branch to repeat the process to move from register memory to the registers. However, if you see in this solution, we haven't really increased register 4, and up to B, the register 4 is always 0, and in our case our R2 is always 2000, so we are actually keep repeating moving data from 2000 to register 3, and from register 3 back to the 8000. So we never have chance to copy anything from 2004 or even 2008. So something have to be done on register 4 so that it increase the value every time we repeat the loop. Well, as you might guess, we have to add our register 4 so that every time we finish the loop, the R4 will increase by from 0 to 4, so that next time when we try to load or store from the memory to the register, or from the register 3 back to the memory, instead of 2000 plus 0, now we have the R0 as 2000, but the R4 has increased by 4 as what we done in the add instruction. So now instead of we move the value from 2000, the address is actually 2000 plus 4, which is given by R4, and we are moving B instead. And then at the same time we store the B from the R3 back to the memory. The address is given by R1, which is 8000 plus 4, and end up to be 8004. So of course we're gonna, after this we add R2 bit 1, which is our counter, then it end up to be 2, and we also add R4 bit 4, so instead of 4 now we have 8. Then we compare R2 whether it is less than 3, right? Remember we have the less than there. If yes, then we're gonna repeat. So since R2 is only 2 and we try to, this is really less than 3, then we go to repeat again to move or to load the value from memory, which is given by R0 or 2000 plus R4, which is at this moment is already updated to 8. So we have a new address which is 2008. So the value we try to move is C, so to R3, and the same time after that we store back R3 to the R1 and plus R4, which is the address, which means 8000 plus 8, which is 8008, and R3 to store C there. Then we increase our R2 by 1, so now R2 has become 3. We did increase R4 by 4, so it become 12, or in hexadecimal it becomes C. So however, when you compare R3 with 3, and your condition to branch is this is R2 is less than 3, and unfortunately this condition has failed, then the processor will not repeat the process again, and it will go to whatever instruction that you have afterwards. So although we didn't really save a lot of instruction compared to our previous video, However, if you have to do this over 30 times, so we just have to modify our compare condition. Instead of 3, now we have to do 30. Then we do really save a lot of instruction codes.
That concludes the topic today, and hopefully I will see you again in future videos.